Hello guys, hope you are doing absolutely fine. Today is the day 14 of our challenge and let's start with the forecasting with line graphs today. And this one is very important pattern where we'll be seeing how the forecasting works in the world of AI. So if you see this image where we are showing the sales forecast, you can see on the x horizon we have like taken the months, that's a time, and on the y axis we have this um, how many rupees or dollars we have earned and how many sales we have done. So what you can see over here, there are like two components. The blue line is showing the historical data and the red is the forecasted um, prediction, like that's how your progress of the sales should go forward. And this is one more example over here. Similarly over here as well, you can see the months on the x-axis, and on the y you can see the difference from average percentage degree Celsius. Or okay, yeah, I think that's a percentage degree, like how much what is the slope of this graph maybe. And you can see the red line over here in the vertical, that's showing the observation, and on the left hand side from that red line, and on the right hand side it's a forecast. Now you can see the black line which is in the middle goes somewhere there, and there is some sort of 68% of relaxation. So that's a dark gray area, and there is a light gray area, and it covers like 95% of the forecast. So now what do we understand from this graph? That's what we want to discuss over here. See the percentage of forecast, so it shows the error rate. Okay, there will be like the uh, you know uh, so basically over here there are like two kinds of data, uh, which is r square, that we will see in some time. But the forecasting with line graphs, over here if you see, we have seen this practically used in many of these areas where weather, weight loss gain, product demand, stock market performance, time takes for. So what is like, whenever you want something to predict like how much time it will take to growing crops, for pipe to rust, maybe a septic tank to fill, global warming to kill all of us. Yeah, so that's what does it show? So based on this graphs you can actually prepare earlier, so it's kind of a loss preversion, or maybe just be ready for some sort of upcoming maintenance work or something. So it's like fairly used at many places. So let's see the previous screen now. So here you can see the 68% what they are showing. So it's just top side and the downside of the prediction. So prediction can go in both ways. Whenever we are saying that okay, this number can go up to this number, so that up to is called the top limit, and it can go down to this particular number, so that can be called as a down limit. So here we know that's kind of the factor of variability will stay whenever we are doing any predictions. Okay, now we will see some of the mathematical concept behind this graphs. So as a designer we just need to understand like how these graphs are being made. It's not that tough. It's just a basic understanding what we can get over here. So based on that, maybe in future whenever we have to discuss the same topic with maybe product managers or engineers, then we have some vocabulary and some understanding like how these graphs are being created. So now if you see the blue dots over here, historical sales, okay, so those are like scattered in some sort of proximity, and if you just draw a line which is like which has kind of an average line which goes between them. So then that is called linear regression. And there is also an equation for that. So if you see, the y is equal to something x minus something, and r square is equal to 0.84. Now you can see the forecasted sales is in orange color there. So that one shows that okay, it should go ideally on a line. So that's what we are predicting from this linear regression equation. And here r square is equal to 0.84. Let's understand that. What is it? See, r squared 0.6. On the first top left corner, you can see the dots are scattered, you know, kind of randomly. But if you see on the b, it's very close to the line. Okay, and see the r squared value there. So in the first one it's zero point 0.6 and this is 0.9. So the r square value should be closer to 1, then it is like a, it will be much more accurate. So just understand this. Okay, this we need to just memorize it. Okay, that r square needs to be near 1, because then if you see on the bottom, that b line has like very tighter prediction. Okay, the top end variation and the down end variation is like very close to each other. While if you see in the r squared, if r squared is zero point 0.6, and then your prediction can go anyways, and that could be, you know costly in some cases. So that's so whenever we are getting any data, if you are getting your r squared value near to 1, then that means that okay, this data is much more, in terms of linear regression, you can bank on it. So there are some disadvantages. This does not indicate the direction. That's true, that we don't know like what this value shows. There is no direction, the upside or downside. It's just a positive value. So it's just value, it's not a direction. And need to understand overshooting and undershooting effects on a given scenario. So yeah, that's what we discussed, right? That what is the overshooting scenario and what is the undershooting scenario. Sometimes that could be costlier. In that case, we can just use r, because r is sometimes much more reliable. So we know that okay, this r value is not going to overshoot or undershoot sometimes. Then uh, there is also one beautiful quote, that while most professions make a living with their knowledge, UX people make a living through their ignorance. So I mean, sometimes what we are doing, so we are finding gaps without having any, expertise in that particular department. So it's kind of seeing like a normal person and seeing the gaps in understanding. So as a UX people, we should do that often. That whatever new industries you take, just question from the fundamentals of it. Okay, like why is it like this? Why is it like that? You find the find the answers through reasoning, and you ask more questions, and finalize like what do you think there are like gaps in understanding of that particular domain. So yeah, that meaning is like quality of UX questions matter. So once you get into asking questions, so yeah, you should ask good questions. So it's okay, in beginning you can ask anything, but yeah, the better as a designer you ask really good questions, the you are going to find really good answers and insightful answers. Okay, then also we will see, this is non-linear regression. So it's not a linear one. Now you see the data, I mean you can draw a straight line through it, but sometimes you have to understand that not all the graphs should fit into that way. So now this is the plot of chlorine versus weeks. So how the chlorine is degrading over the weeks. So if you see the first 10 weeks, it's almost the chlorine is not that much degraded, but over the time, over the 40 weeks, 50 weeks, you can see it's coming closer to 0.4, 0. You know 3538 something. Now, um, now you see there are two things coming out. There's no straight line, it's a kind of a curved line going from there, and there are two lines in this graph. One is the blue, one is the red. Blue is reciprocal x, and the red is fourth order polynomial. So fourth one, so what does it mean? What do you mean by that? So it's kind of two graphs over here, but I mean those both are mathematically almost correct graph, but both has like slightly different curvature there. So in non-linear regression, you just need to understand, like sometimes you don't have to force fit everything into predefined mathematical this thing. You just see and observe like which is the best in this case. What is the best scenario we can use this graph. So this is just to have discussions with your team members, that okay, why you have chosen this graph, why, what was the reason, like why do you think this graph is the best, what is the algorithm you chosen for this use case. So that is the requirement. Then next topic is seasonality. So not everything is linear and not everything is non-linear. Sometimes is a we need a graph which shows seasonality, like when we have in e-commerce websites, we have this Amazon, I think Amazon day or something, big billion days and all. So in those cases, those are the like surge dates where there will be a lot of traffic coming to your particular website, a particular product. So maybe you can adjust your subscriptions based on that to manage the traffic there. So if you see there are some examples written. So if you overestimate Cyber Monday traffic, your AWS bill will be slightly higher. Okay, so you thought that okay, this many visitor will come, but there are many few visitors came. So you are basically overestimating your prediction. So I mean you are getting a slightly more AWS bill because you have maybe you have purchased that much of bandwidth at that particular moment. So and if you underestimate the traffic, you can go your website will be crashing, and all the shopping carts will be erased and search session information, and it will cost you a millions, right, for every minute of outage. So I mean that's where you have to understand like what should be, how should I pick the R square value. Should I overestimate or underestimate, like what should be, what should cost me, and in that case so you have to be a slightly cost aversion mindset in that case. And AI works pretty well in this scenario for forecasting. So yeah, seasonality is one of the best use cases where AI is utilized in current days. Yeah, that's for today. We will be seeing this next chapter in tomorrow's. Thank you everyone for joining, and yeah, I'll see you in the next one.